All right, so today's lesson is on 9.3, probability of compound events. So far, what we've done is a lot of simple events. So now we're going to move on to the compound events. So let's go ahead and define this. First of all, we're going to define what is a compound event. And it's simply more than one event or more than one thing happening, right? More than one event. So for example, that would include like flip a coin. Flipping a coin is a single event, and rolling dice. So flipping a coin is a single event, rolling dice is a single event, but together they are a compound event, right? That kind of makes sense, right? So we have anything, it could be 2 things, 3 things, 4 things happening, and we're going to see the likelihood of those certain things happening. So let's go ahead and do an example of a compound event. All right, go and write this down. The first one is, let's do this example. What is the probability of getting heads let's say getting heads twice in a row? What's the probability of getting heads twice in a row? Okay, so what I'm looking for is you can write it this way, the probability of getting heads and then heads again. So what I want to look at, we'll take this a little nice and slow, is what are the different options that we have? Okay, so what are the different things that could happen? So we're gonna flip a coin twice. We're gonna flip it, see what we get. We're gonna flip it again, see what we get. Okay, so on your first flip, you have 2 things that really could happen, right? You can get a heads, or you could get a tails. Okay, on your first flip, you can get a heads or a tails. On the second flip, say flip 2, you could get, well, if you got heads first, you could get heads again, or you could get tails. And if you got tails first, you could get heads, and you could get tails. So if we follow these what I call paths, okay, on these kind of on these trees type, because they're kind of like branches here. If you follow the paths, you'll see what you could end up with. So for example, follow this path of heads, heads. This is what we want. We end up with, okay, well, we're gonna call our, oh, sorry about that. We're gonna create what we call our sample space. Our sample space is all the possible outcomes. Like, what are the actual outcomes? Not how many there are, but what they actually are. So, for example, our sample space here, we could get heads, heads. If I follow another path, right? I follow this path, I end up with heads and tails. This one I would get tails and heads, and this one I would get tails and tails. So again, just follow the paths. You'll see, right? Here's tails and tails. Here is, do a different color here. This is tails and heads, gets us there. So the another vocabulary word here is this is what we call sample space. Sample space is just all the different things that could happen, listed out. So if you've ever seen like what is in the sample space, is this a part of the sample space? That the question's asking, is this one of the possible solutions? Okay, so the question was, what's the probability that we'll get head to head? So what we want to do is we want to count. There are 1, 2, 3, 4. So there are 4 possible solutions, right? And heads heads is only one of them. So the probability of heads is there's 1 out of 1, 2, 3, 4. So a 1/4 or 25% chance. So this is a compound event, right? This is a compound event. You're trying to figure out, okay, what is the probability that I will get heads, right? Two different things. And so we know it's a 25% chance, right? There is a 1/4 or 25% chance. Now, another way you could look at this is you could look at the individual probabilities of each. So, for example, I could say, well, I know the probability of getting heads one time is 1/2, right? The probability of getting heads is 1/2. The probability of getting heads again is also 1/2. So guess what? If I just multiply those numbers, I'll end up with my 1/4. So, but I basically did is I found the probability of each thing, okay? And then I multiplied them together, right? So basically the probability of heads and the probability of heads again, and then I multiplied those together to get my 1/4. Let's look at another example. What's the probability? Okay, let's say I'm going to flip a coin and roll a number cube. What is the probability that I will get a 4, or sorry, that I will get a tails and the number 4? So I want to know the probability of tails and 4. Okay. What's the probability of me getting tails and the number 4? All right, so what I'm going to do is I'm going to take this strategy that's kind of shortcut. I could draw it all out, right? I could draw it all out and find the sample space. Okay, you don't write this down. I could say, okay, well, what's the probability of me getting, there's heads, and then there's 1, 2, 3, 4, 5, and 6. And then there's tails, and 1, 2, 3, 4, 5, and 6, right? So I could do it this way, and I could kind of map them all out and see which ones I want, right? The only one that I really want that I'm concerned about is tails and 4, which is this one right here. Or again, I can do it where I find the probability of tails and I multiply it by the probability of 4. So if you think about it, what's the probability of getting tails, right? Probability of getting tails is 1/2, right? And the probability of getting a 4 is 1 out of however many numbers are on a number cube, right? There are 6 numbers, so there's only 1 4. So the probability of getting a 4 is 1 out of 6. So what I'm going to do now is I'm just going to multiply those together. So 1/2 times 1/6, which is simply 1 out of 12. So you have a 1 in 12 chance of getting a tails and then the number 4. So there it is, 1 in 12, 1 out of 12. And you can divide and find the percentage by dividing and moving that decimal 2 places over. All right, let's do one more, make sure we got it here. What's the probability that you'll get tails, tails, and tails again? what's the probability that you'll get 3 tails in a row? So you're flipping a coin, you're going to flip it 3 times. What's the probability that you will get tails, tails, tails? Well, again, all you need to do is find the individual probabilities and then multiply. So find the probability of getting tails, probability of getting tails, and the probability of getting tails, and then multiply it out. So let's see. Probability of getting tails once is 1 out of 2. Now, every time you flip, whatever happened last time doesn't affect it, right? It's a new flip. So even though you don't think it's likely that you'll get another tails, it doesn't matter. It's still 1 out of 2. So the probability of the second tails is still 1 out of 2. And then lastly, the third tails, well, the probability is still 1 out of 2. So now I just multiply across. 1 times 1 times 1 is equal to 1. 2 times 2 times 2 is equal to 8. So I have a 1/8 chance, 1 out of 8 chance, or I believe 12.5% chance of getting tails, tails, tails. And if you want to double check that, again, if you really want to look at what the sample space is, you don't have to write this down, but you can, let's just take a look and break it down really quick. I'll just kind of draw it out. So I got flip number 1, I got flip number 2, and flip number 3, and that'll create our sample space. So let's just draw this out really quick. So I could get heads, or I could get tails. From there, I could get heads, or I could get tails. From there, I could get heads, tails, or heads and tails. And from here, I can get heads and tails, or heads and tails. So I know this is looking a little bit confusing, but to figure out, again, follow the tree, follow the path. So one option is heads, heads, heads. Right. And I can do the same thing here. You know, heads, heads, tails. All right, so that's what I'm looking for. So on and so forth. So I can, heads, tails, heads, heads, tails, tails. Oops, sorry. And then the same thing will kind of repeat down here, right? I could get tails, heads, heads. I could get tails, head, tails. Just keep using different colors here. Tails, heads, tails. So you can see how that works. So on and so forth, right? Tails, tails, heads. And finally tails, tails, tails. So the only one I really care about, the one I really want, is tails, tails, tails. There are, how many options are there? So there's only one that I want, and there are, 1, 2, 3, 4, 5, 6, 7, and 8 choices. So there you go, 1 out of 8, like we said. Now, we, of course, don't need to do this the whole time. We did it really simple, just using multiplying the fractions. But I just want to show you, again, using that word sample space, so you can see what sample space is. Again, sample space is just all the different things that are out there, all the different possibilities that are there. So these are the 8 different ways, 8 different things that could happen. The only one that we were looking at was tails, tails, tails. And so the probability of getting it is 1 out of 8. Okay. So let's look back. Okay, let's review this really quick. The compound events are more than one event. Sample space are all the possible things that you could look at. So let's highlight this here. Okay, sample space is what we talked about a little bit. Okay, and then the key is right here. Again, find the probability of each part and then just multiply, right? So probability of heads times the probability of heads, get to the probability of heads, heads. Okay, same thing here. Probability of tails times the probability of a 4, and you get multiply those together, and you get your final. Okay, and right here, tails, tails, tails. Again, I just gave you a quick little example towards the end here, sample space. But really, the key is right here to saying, okay, probability of tails is 1/2 times the probability of tails, which is 1/2, times the probability of tails, which is 1/2, 1/8, or 12.5%. All right, so that is how you find probability of compound events.